Okay, so we've already looked at adding and subtracting rational expressions with like denominators. Now we're going to look at adding and subtracting rational expressions with unlike denominators. So again, we're going to use the same rule to add and subtract rational expressions that we use to add and subtract numerical fractions. But this time we're looking at getting common denominators first. Because in order to add and subtract, you must have common denominators. So our denominators are the numbers on the bottom. So 5 and 15 are our denominators. The process is to find the prime factors of each one. So 5 is already prime, it's 5. 15 is 3 times 5. So we look at what they have in common. They have a 5 in common. Then we look at what we didn't circle, what they don't have in common. They don't have a 3 in common. So we're going to multiply what they do have in common, 1, 5, times what they don't have in common, a 3. So the LCD is 15. Now, some of these, you may be able just to look at them and tell what the LCD is. That's fine. I'm just showing you a method to finding the LCD in case you can't determine what the LCD is just by looking at it. All right, now we're trying to decide 5 times what number is 15? All right, well, that's 3. So 5 times 3 is this 15 right here. So what we're going to do is multiply the numerator times 3 to get our new numerator for our new LCD. Same thing over here. 15 times what number is 15? Well, that's already the same because when you multiply by 1, you get 15. So we're going to multiply the 4 times 1. So this fraction doesn't change. Now that we have common denominators, we're going to do like we did on the other video. Keep the denominators the same and add the numerators. So that's 13 over 15. So this is just a little review of adding numerical fractions. Let's look at subtracting numerical fractions. So our denominators are 4 and 7. So 4 is 2 times 2. 7 is already prime, it's 7. There's nothing they have in common. So we're going to multiply everything together. So 2 times 2 times 7 is 28. So 28 is the LCD. Okay, so 4 times what number is 28? Well, that's 7. So we're going to multiply the 3 on top times 7. So that's 21. Now, 7 times what number is 28? Well, that will be 4. So multiply the number on top of that fraction times 4. So we get 8. Now we're subtracting. Keep the denominator the same. Then subtract the numerators. So this will be 13 over 28. So that's the same rule we're going to be looking at when we're looking at these rational expressions. All right, so this first one just says to find the LCD. So the LCD we're looking for is of the denominator. The D stands for denominator. So 2x and 7x. 2x, breaking it down, is 2 times x. 7x is 7 times x. They have an x in common. They don't have in common the 2 and the 7. So we multiply what they have in common times what they don't have in common. So the LCD for this problem is 14x. It's the lowest common denominator, or least common denominator. All right, on this one, our denominators are x plus 4 and x minus 4. So a while ago, I was doing the factors of 2x and the factors of 7x, and that's what I did was 2 times x and 7 times x. So here, I'm doing the factors of x plus 4 and the factors of x minus 4. Well, these are binomials with an addition sign or subtraction sign. There's no other way to factor these anymore, so they don't factor anymore. Okay, so what we're going to do is multiply x plus 4 and x minus 4. Now that is the LCD. Don't factor. It says do not distribute, do not multiply, do not use FOIL, do not. Okay, so you're just going to write it as x plus 4, x minus 4. To me, those are the easiest kind. Okay, so now let's look at actually adding rational expressions with unlike denominators. All right, so we have our denominators, 4x and 2x squared. And again, this is a method that you can use if you don't know what the LCD is. If you know, you don't have to go through this process. All right, so 4 is 2 times 2, and then we have times x. 2x squared is 2 times x times x. So they have in common a 2. They have in common one of the x's. They don't have in common a second 2 and a second x. So multiply all those together, and our LCD is 4x squared. So this is our common denominator, our lowest common denominator. All right, so we're going to see what times 4x is 4x squared. Well, you can divide 4x squared by 4x, and that will tell you what times 4x is 4x squared, and that will be, oops, x. Let me try that again. So I'm going to multiply the numerator for that first fraction times x, so that's 5x. Do the same thing here. What times 2x squared is 4x squared? Again, we can just divide. 4x squared divided by 2x squared, well, that would be 2. 2 times 2x squared is 4x squared. So multiply the numerator times that same 2, and we get 18. So keep the denominators the same and add the numerators. Now, 5x and 18 are different terms. You can't add them together. So that's my answer. All right, number 4. Now, when I'm adding fractions, if I don't have a fraction that I'm adding to another fraction, I want to make it look like a fraction. So that's why I did 8 over 1. So one of the denominators is a 1. The other denominator is x plus 8. If one of the denominators is a 1, then the LCD is the other denominator, x plus 8. All right, so what am I going to multiply by 1 to get x plus 8? Well, you guess it. We're going to multiply by x plus 8. So in the numerator, when I multiply by x plus 8, I need to do the distributive property. So that's 8x plus 64. All right, what do I multiply x plus 8 to get x plus 8? Well, I multiply by 1. In other words, that numerator is not going to change. So now we have common denominators. Keep the denominator the same, and I'm going to add the numerators. 8x plus 64 plus x minus 8. So I'm adding the 8x's and the 8x and the positive x, and I get 9x. Then I'm going to add 64 and minus 8. So that will be positive 56 over x plus 8. Okay, 9x plus 56 won't factor, so that's my answer. All right. Number 6. This time, both denominators are binomials, but they can't factor anymore. So the LCD is both binomials, x minus 7, x minus 2. Now, do notice we have a minus sign. I'm going to deal with that minus sign after I get my my new fractions with my LCD. So, what am I going to multiply x minus 7 by to get x minus 7, x minus 2? X minus 2. So, do the distributive property in that numerator, and I get 2x squared minus 4x. What am I going to multiply x minus 2 by to get x minus 7, x minus 2? Well, in order to make that look the same, I'm going to multiply by x minus 7. So do the distributive property, x times x minus 7 is x squared minus 7x. Now, in the previous video, we talked about there's a minus sign there. Okay, after you get your common denominators, after you get your new numerators, now change that minus sign to a plus and change the signs in the second numerator. Do not do FOIL, okay, on that denominator. We're going to combine like terms in the numerator. So we're adding 2x squared and negative x squared. That's 1x squared. Then we're adding negative 4x and positive 7x. That is positive 3x. And we have in the denominator x minus 7x minus 2. Okay? Now that will factor, but nothing will cancel, so you don't have to worry about factoring that one. Okay? All right, so far so good, I hope. All right, number 7. Now, this one says that f of x equals 4x, and it says g of x equals 1 over x. What they want us to do is subtract the two expressions. F of x's expression is 4x over 1. I just put it over 1. G of x is 1 over x. So, we are subtracting these two expressions, 4x and 1 over x. Now, I put the 4x over 1. Again, when you're subtracting and adding fractions, you want to have two fractions. So, common denominators. We talked about if one of the denominators is 1, then the LCD is the other denominator. So, the LCD is x. So, 1 times what is x? Well, that's going to be x. So, multiply the top first numerator times x, and we get 4x squared. X times what is x? Well, that will be 1. So multiply by 1, and our second fraction doesn't change. All right, so both denominators are now x. The numerator is, if you want to change that to a plus and a negative, that's fine. So that's 4x squared minus 1. And that goes in that blank. Okay, last one. Now, this is a complex fraction again. And we talked about this before. In a complex fraction, I want to make it where it's not so complex. So, the LCD. You notice that my denominators are a w, an x on top, and a w, and an x on bottom. So, I have 2 w's and 2 x's. They're already factored. They're already monomials. They don't factor anymore. So they have in common 1 w, and they have in common 1 x. So my LCD is wx. Now, instead of making these into common like fractions, fractions like denominators, I'm going to instead clear the fraction. So I am going to multiply everything by wx. Now, we're going to do this in the 11.5, so I'm going to go ahead and start now. So we're putting wx in each numerator. And then we're going to simplify. Let me do it down here. Wx in each numerator. Okay, so here the w cancels. So I have 6 times x. Plus, here the x cancels. So I have 5w. In the denominator, the w cancels for the first term. So I have 5x minus, and then my last one, the x's cancel, so I have 6w. Now, neither one of these, numerator or denominator, factor. That is my answer. All right, so that is adding and subtracting fractions with unlike denominators.